Right now, you're being pulled toward the center of the Earth with a force of, well, your entire body weight. But here's the thing, gravity isn't actually a force pulling you down. At least, not in the way you think today. We're breaking down what gravity really is, why it's the weakest force in the universe, and how it connects to the most extreme objects. Let's dive into the invisible force running your entire life. For over 300 years, we thought gravity was a force. Isaac Newton figured out the math: every object with mass attracts every other object. The bigger the mass, the stronger the pull. That's why Earth pulls you down, and why the Moon orbits Earth. But in 1915, Albert Einstein dropped a bombshell. He said, gravity isn't a force at all, it's the curvature of space itself. Imagine space is like a stretched out bedsheet. If you put a bowling ball in the middle, it creates a dip, right? Now roll a marble near it, it spirals toward the bowling ball. The marble isn't being pulled, it's just following the curve. That's gravity. The Earth is so massive it warps the fabric of space and time around it. And everything, including you, is just following that curve. You're not being pulled down. You're sliding down a slope in space-time that you can't see. Here's something wild. Gravity is the weakest force in the universe. Think about it. You can pick up a paperclip with a tiny magnet. That little magnet is overcoming the gravitational pull of the entire Earth. 6 trillion kilograms, and a dollar store magnet beats it. So why does gravity feel so strong? Because Earth is massive. It's the biggest thing you interact with daily. Gravity is so weak compared to other forces, scientists still don't fully understand why. It's called the hierarchy problem. If gravity were as strong as electromagnetism, you wouldn't be able to stand up. You'd be crushed into the ground by your own weight. So if gravity is so weak, how do we get black holes? Answer: density. A black hole is what happens when you pack an insane amount of mass into an incredibly small space. The gravity becomes intense. Here's the mind bender. If you replaced the sun with a black hole of the exact same mass, Earth wouldn't get sucked in. Get close enough, and the gravity at your feet would be stronger than at your head, stretching you into a human noodle. Spaghettification. Black holes also slow down time. Near the event horizon, time moves slower relative to the outside universe. Gravity isn't a force pulling you down, it's the curvature of spacetime. It's the invisible architect of the universe. The next time you drop your phone, remember, you're witnessing the same force that creates black holes and holds galaxies together. If you enjoyed this, smash that like button and subscribe. What should we explore next? Thanks for watching.